Okay, we are going to take real problems, and I don't know how real this is, but well, it's just pretty real, and try to write equations. Okay? So that we can make predictions. So this is a linear model because these are going to be lines. That's why they call it a linear model. They're going to be lines. Now, a linear model may not be the right model, but we're going to try it and see if it works. And since that's all we know, it's going to be the right model. You can write the equation for a linear model in the same way you write the slope-intercept equation of a line. Y-intercept of a linear model is the quantity that does not depend on x. It's the fixed amount. It's a fixed number. So like in this example, when you have a salary and then you get commissions on anything you sell. That salary is not dependent on how many things you sell. I'll always get $40,000. Okay, that's the way that works. The slope is the quantity that changes at a constant rate as x changes. How many of you have jobs? You say to me. You have a job, Adine? No? Andrew, do you have a job? So you get an hourly pay? What's the going rate for teenagers today? $8 an hour? More? Pardon? About? So the amount of money you make, what we call it D for dollars, is equal to $8 per hour times the time measured in hours. So if you work 1 hour, you make $8. If you work 2 hours, Andrew, how much do you make?
2 hours.
Yep, that's $16 an hour. How much do you make? Sorry, that $8 an hour? I think I answered the question. Yeah, you should be logged in. If you work for 2 hours and you're making $8 an hour, do you work? You will be $16, right? That's a linear model. So you're going to have to read these problems and try to figure out what's going on here. And that's going to be the hard part, I'll be honest with you. Okay, a machine salesperson earns a base salary of $40,000. What I like to do when I do word problems, because I don't like word problems either, Keaton, I like to write the numbers down. So, is that a lot of money? $40,000 in a year? More than a teacher makes. More than a first-year teacher. They don't make that much. So he's going to make $40,000, and he makes a commission of $300 for every machine he sells. In fact, we can write a table here and see if we can figure this out. So here are the number of machines. I'll abbreviate that way. And here's the amount of money he's going to make. And so it talks about, I want the total amount of income, and it's the number of machines is X. So this is going to be X, and we can call this, you can call it Y, I'd rather call it income. So if he sells one machine, how much money does he make on the machine? $300. What I'm trying to do is get the slope. If he sells 2 machines, how much does he make? $600. If he sells 3 machines, how much? $900. Okay. If he sells no machines, he doesn't make any commission. That's just the commission. So how much money is he going to make? Actually, my table's not as accurate as I'd like to be. What's his income? He's going to make $40,000 plus, what if he sells X machines? How much is he going to make? Once he looks tired today. If you sell 1 machine, it's $300. 2, it's $600. 3, it's $900. How am I getting these numbers? I'm multiplying these numbers by what? Not 3. Close. 1 times 3 is 3. I want 300. What am I multiplying by? 3 times what gives you 900? 300. So what if I sell X machines? I'm going to have how many? How much money am I going to make? We can keep going. Let's not multiply this out. What if it's 4 machines? What do you do? You're right, it's 1,200, but what do? You multiply 4 by what? 300. I'm looking for patterns. I'm looking for the slope. If you do 5 machines, it's 5 times 300. Need a pencil? Oh, I forgot to bring some on my car. We're out. What if you do 6 machines? It's what? Look at the pattern here. Good. 6 times 300. What if you do X number of machines? It's X times 300. So that's what you're going to make. So your income is 40,000 plus, and it's 300X. That's your hourly rate of pay, if you want to think of it that way. This is the slope. So we're going to try to write the equations, and maybe we'll make predictions after that. Let's try the next problem. Oh, they give us the equation. Okay, they give us the same equation, and they do this on the AP exam too sometimes. You have to find something, but you know what they do then? They give you the answer because they want you to continue working with the correct equation. So they give it to us now, so we know we did it right. What would be the salesperson's income if he sold 150 machines? How could I do that? How could I find out? Where do I put 150? I put it in this formula, 150 times what? Andrew, you're right, I think. Yeah. That's what X is. That's how many machines you have. So you substitute it in there. And 150 plus 40,000. I suppose you guys want a calculator, don't you? Okay, do you want this job? Are you going to make good money? You're going to make 40,000 and you're going to sell 150 machines at $300 profit to you. Trust me, when you go to the stores and you buy groceries or you buy clothes, the profit is incredible. Those $100 pair of shoes cost the store about 10 bucks. That's why they can discount things at the end and sell them for almost nothing. The markup on shoes is incredible. Very, very cheap. What are you looking for? Oh, there he goes. So, now do you remember the easy way to multiply it? I don't have a calculator handy, so I'm not going to use one, because I know what 3 times 15 is. What if I thought I changed colors? I'm having issues with pressing buttons these days. 3 times 15 is how big? 45. And then do you know how many zeros you're going to add in? 1, 2, 3. 1, 2, 3. Plus 40,000. I'm going to put my commas in there so I don't mess up. And I'll write this in columns so that I don't mess up also. That's not bad. That'd be good money. How much money is that? 85,000. That's not bad. Are you willing to do this job? Depends on how hard it is to sell machines, but if you can sell 150, not too bad. Now that was in what? A year. How many days in a year do you guys know? 365. That's about half a year. So every other day he's selling a machine, he or she. Okay, let's try this one. At a school play, children's tickets cost $3 each. Oh, this one's going to be a little different. And adult tickets cost $7 each. So I'm going to say this. Children is $3 each. And adults, you know, kids take the same space. I don't get that. Anyway, $7 each. Are you guys going to go to the play? Legally Blonde? They make money. You know, why do they charge so much money? Do you guys know why? No? They have to charge that much money because they have to buy the rights to put on the play. And then they have to do all the costumes and they have to do the sets. They're not really making money, but when they get that money, they have to pay a lot of money to get the rights to put on the play. Okay, Aideen, put that away, unless you're doing Schoology, which you're not. Okay, the total amount of money earned from the ticket sales equals $210. This is going to be a little bit different form. I'm hoping the rest isn't y equals mx plus b. It's $210. So, what would you like to call the number of children's tickets? I don't really want to use X and Y because I'm going to forget which one's which. Would you like to? Well, what's a good letter for children's tickets? C. So C is equal to the number of children tickets. And how about the adult tickets? A. And you're going to see a different form of the equation of a line. If you sell one, now let's do the children. If you sell one kid's ticket, they're going to make $3. What if you do two? So it's 2 times 3, right? What if you do 3? 3 times 3. What if you do 4? 4 times 3. What if you do C number of tickets? C times 3. So what I'm doing is taking this number and multiplying by 3. Not slope, similar, but it's not slope. What about the adult tickets? Those were $7 each. So if you sold one, you're going to bring in, how much, Lindsay? 7. If you do 2, well, 7 times 2. What if you do 3? 3 times 7. Let's write this the other way, 2 times 7. What if you do 4? 4 times 7. What if you do A? A times 7. Okay, so how much money do you make? Well, you make the, here's the plan. It's the amount of money from the children's tickets, plus the adult tickets, and they told us how much money they made. How much money did they make? $210. Now, how much did they make from the children's? I don't know how many children's tickets they made. They sold, but they have 3C. How about the adults? How much money do they make from the adult tickets? What do you think? If it's 4, it's 4 times 7. I don't know how many it is. So it's A times 7, or 7A, equals 210. Do I know what A and C are? No. I don't have enough information to know how many of each they sold. I could figure it out, but that's more than what we want to know. And that's all they're asked to do. Okay, except I have to copy that equation down, which was 3C plus 7A equals 210. 3C plus 7A equals $210. Now, it says how many children's tickets were sold if 24 adult tickets were sold. Where am I going to put the 24? What? What? Oh, okay. How many, if I sell 24 adult tickets, what do I do with the 24? Where do I put that? You got a 50-50 chance. It's either A or it's C. Where is it going to be? It's where A is. 7 times 24 equals 210. And you're probably going to want a calculator. Anybody have a calculator? What's 7 times 24? I could cheat a little bit. It's like 7 times 25. And you say, well, that's no easier. How much money is 7 quarters? Keaton, how much money is 7 quarters?
168.
7 times 25. Is it 168? That would be 175, right? $1.75. But we're short a penny 7 times. He's right. 168 equals 210. That's how I do shorthand arithmetic if I have to. Because I'm so used to calculators, you need to put that away because you're not doing this, since you don't have this open. I know, I'm so mean. Because you're not paying attention. How do I solve for C? Adam, how do I solve for C? We've done this. This is old. Wake up, it's Monday. It's snowing. It's April. How do you solve for C? We had tornadoes last night. What do you do? Do you know, Nick? Evan, do you know?
Subtract 168.
Very good. We subtract 168, because I'm going to leave you guys to try these problems. We may not get very many done. That's okay. At least we've tried, and we've seen what's happened. Why do we write equations of lines? I got to know my tickets to print up, for one. Oh, I should subtract. 42? Well, let's see if that works. Let's add. 2 and 8 is 10. Carry the 1. 4 and 6 is 10, but the 1 is 1, carry the 1, 210. That looks good to me. And how many times does 3 go into 42? We should know how to solve this once we get to this point. 3 into 42. Lindsay, do you know? Remember long division? 1 times 3 is 3. 4 minus 3 is 1. How many times does 3 go into 12? Adine?
0.07.
No, 3 into 42. Other way around. How many times does 3 go into 12? Andrew?
4.
4. Oh, I know you guys know this. You're just not interested. Not a choice. We have to do this. This is part of the curriculum. Yeah, we should be doing word problems because that's applying everything we've done. Otherwise, doing all the stuff we've done is worthless. Why are we doing it? We learn algebra so we can solve problems. Okay, there's your practice problem. Let's do the first one together, and you have a piece of paper. You can either write on your iPads, and it's right there, but a lot of you don't have it. And you do this in science class. Okay, so you need another piece of paper. This is the reason why this isn't a good thing for you. Because you're not paying attention. That's the reason. And you have this on your handout. Hey, I can check my answers. Did I do them right? Oh, I didn't put that question in there, I guess. I missed one. That's okay. Lynn is tracking the progress of her plant's growth. How more appropriate than to talk about plants' growth today? Because we should be planting things in the snow. Today the plant is 5 centimeters high. Okay. So today the plant, here's my plant. Actually, I'm a pretty good artist, but anyway, this is 5 centimeters. And then the plant is growing 1.5 centimeters per day. Okay, so let's make a real table of values that will give us the equation right off. And if you can write the equation without a table, be my guest. I can do it, but I don't know if you can yet. So write a linear model that represents the height of the plant after D days. Yeah, but you're not on the right page anymore. You got to go to the right page. I forgot how to do that. Okay, so let's, what do you want to use for variables? Just x and y? Doesn't matter. So x, or how about time? How about t and h? In the beginning, we're going to start at t equals 0. What's the height of the plant? How tall is that plant when we begin? How big? You got to read. 5 centimeters. This is what's going to happen on the MCAs. They're not going to be like the worksheet problems I give you. They're going to be like this. So you can, on your iPad, if you have an iPad, you've got plenty of room to write that down. Okay, Keaton? So if you don't have a piece of paper, or if you're going to use your iPad, whichever, you need to write this down. You want me to find your paper if you don't have any? This is 5 centimeters, right? It's kind of nice to put this in. This is just like science class. How tall is this plant after a day? Adam? How tall is the plant after a day? It grows 1.5 centimeters per day. It was at 5, and how much is it going to grow? Right? 1.5. So that's going to be what? 6.5. Pardon? Yeah, you can keep adding, but that's the slope. So after day 2, you're at 6.5, and you're going to add 1.5. That's equal to what? Ooh, does anybody know that at the top of their head? 1.5 is... No. 1 and 6 is 7, but what about the 0.5 and the 0.5?
8.
That's going to be another 1. 1 plus 7 is 8. That's mathematics. Manipulating numbers so I can do it. Keaton, you're supposed to be writing this down. If you don't have a stylus, you can write it on the white paper. That's not. I didn't give you space. You really need your own paper. Okay, one more. You're 8 plus. What am I going to add to that 8? And the third day, Is this a good model? What if this plant grows 1.5 centimeters per day for 365 days? It's going to be rather tall. Are we talking Jack and the Beanstalk here now? It's a good model for a short period of time. It doesn't hold for everything. But right now, we'll say it's 1.5 centimeters. It's going to be a tall plant. How tall is it going to be? 9.5 centimeters. So the height is going to be equal to the plant growth. That's the slope. And I also have a clue on that. Times, and you could do it dimensionally if you want, the number of days plus where it begins. Does that make sense? This is the slope. That's how fast it's growing. That's your rate of pay. $1.50 a day. Not very good, is it? So the height is going to equal, what's the slope here? As this increases by 1, what is this increasing by? 1.5. So that's 1.5 times how many days, and we call that T, plus, what was the beginning height? Didn't start at 0. Started where? How tall was the plant when I bought it from the store? 5. Should we check to see if this works? Let's try the height after 3 days. So we have it in our chart after 3 days. You could do y equals mx plus b. You can do that too. It doesn't matter because that's what this is. The height is going to be equal to 1.5 times, what, 3 plus 5. What's 3 times 1.5? What's 3 times 15? We did this one already. 3 times 15. Shake, 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 shake. Wake up. 4.45, right? And you count back 1. What's 4.5 plus 5? Okay, if we don't know, why did we do all that work in the beginning of the year? We line up our decimals, so it's 9.5. Or you use a calculator. I'm not going to have calculators because of the MCAs. So you're going to have to use your own. Does that match what I have right up here? Yes, it does. Seems to work. Oh, that was part A. Whoa. Well, no, I can write it right away. If you can write it right away without doing a table, do that. But I don't know if you're going to be able to do that. When you see this ratio here, that is the slope. And we're going to do, I haven't done all the problems, my guess is it's all y equals mx plus b. And b is the beginning. So what will the height of the plant be after 20 days? What's going to be 20 down here in my equation? T or H? What will the height be after 20 days? Where are you going to put the 20 in, for T or for H? 20 days. Lindsay? Keaton? You guys going to watch this video later, aren't you? Okay, what's the height going to be after 20 days? Where does the 20 go? Evan? You have 50-50 chance. Either goes in for H or it goes for T. H stands for height. T stands for time. Where does the 20 days go? Time. Okay, so I'm going to put the 20 in there, and we can do this without a calculator. And so H equals 1.5 times 20 plus 5. Sometimes just some mental math is not a bad thing. I don't care if you use a calculator, but you should know what 2 times 15 is. What's 2 times 15? 30. Just close. And how many places are you going to have to come back? How many places? Think of this, except I'm missing a 0. 2 times 15 is 3, but I have a 0 there, so I got to come back 1. So it's 30 centimeters plus 5. Do you know how big a centimeter is? There's 2.5 centimeters per inch. Do you know how many inches that is? Ooh, that's a good question. It's actually 2.54 centimeters in 1 inch. Nobody wants to know how big that is? How tall is that plant? You have no feel for 30 centimeters. Neither do I. Because we were brought up with inches, which is silly. But anyway, that's what we do. You take your 35 centimeters, and you either multiply by 2.54 divided by 1, or the reciprocal, 1 times 2.54, I'm sorry, 1 over, 1 inch, over 2.54 centimeters. You should be doing this in science class. I want the centimeters to cancel out. So I'm going to multiply by 1 inch, I almost did it wrong, 2.54 centimeters. There's a centimeters in the numerator and 1 in the denominator, and I don't know how big that is, but who's got a calculator handy? I do on my phone. Corey, what is that going to be? You take 35 divided by 2.54, and you get 13.7 inches. So that's about a foot. So it started at 5 centimeters, pretty little, so it'll be about a foot tall. Can it keep growing like that? Does that make sense to keep growing and growing and growing? Unless I'm going to get a what? A tree with the plant. This model only works for a short period of time, because eventually that plant will get to its biggest height. It's the same as you. You keep growing and growing when you're a little baby, and all of a sudden you get to be your height. Some of us didn't get to be as tall as others. Some of us only 5'3". But anyway, that was a limiting value. So I'm going to let you guys try these. Mr. Thompson is on a diet. He currently weighs 260 pounds. He loses 4 pounds per month. See if you can write an equation. Because I'd like to know, if it were me, I'd like to know when I get down to a certain weight. If I could lose 4 pounds per month, I'd be really quite happy. So give it a try. Why don't you try? You're going to have one of these on your quiz or test, whatever you want to call it. You will have one. So you need a piece of paper. Do I have to get some paper here? Do you have some paper? Otherwise, I have some pretty paper. Sure, just use the back of this. Really pretty paper. And try it. Can you write the equation right away? I don't know. And I do have an answer key for this. Oh, I did not give them as many problems. I think I only gave you like 6. And then on problem number 6, we have cell phones. Oh, yeah, I don't think they have enough room on here. Yeah. Adam, you're going to need another piece of paper. And I even have answers. You have to write really small. Let me see how many problems so I can know what every sort of, the max that we will be going through is number 4. So that's all we're going to do today. Okay? And what's this one? Is that the cell phone? No, there's a savings account problem. Where's the cell phone problem? I guess maybe I didn't even assign the cell phone problem. That's too bad. Because the cell phone problem was actually quite realistic. Or you can choose problems. You don't have to do the 4 that we're doing here. Take your 4 you're interested in. I don't care. Because it's all the same. Yeah, so I only put 4 problems up here. Problem number 5 is about savings. 6 is a cell phone.
So now they have to do it.
For 84 problems they want, but if they're doing it on their iPad, there's only the first 4.
Oh.
But I figured that was plenty. Oh yeah, I got to get a clock.
It's almost like
I know, and I'm hungry already. Come on. You know what? This one's better. I think this one changes pages with me. Except it's big. Let me see. Okay, I'm wrong.
40 pounds or be more.
I don't know. I gotta write the equation.
absolutely.
So you're gonna have to define a variable. You can do y's and x's if you want.
Last 40 gets
It's months. Okay, there's months. How much you want? What do you want to call as weight? M equals number of months. We're going to try to write an equation and then solve. Or evaluate. And what would you want to call as weight? How about W? So see if you can write an equation. Remember, it's W equals mx plus v. What's his beginning weight? What's his beginning weight? Oh, thank you. 260. And every month, he's losing 4 pounds a month. So what are we going to do? Add or subtract? Keaton, you need to be involved. Add or subtract? What do you think? You're losing weight. Subtracting. How much every single month? 4 times the number of months. You do this in science class. So that's part A. After how many months will he reach his goal of 220 pounds? Where do I put the 220? Is it months or is it weight? If we can get this part, the next part should be easy. Where are you going to put the 220? You know, let's get down to 220. Still pretty high. How many months is it going to take him? Where's the 220 go? You could do a table of values. I don't know. Am I going to put it here for M or here for W? I'm trying to show you that this is how we use algebra. 220 is the weight, isn't it? Equals 260 minus 4M. Yep, you're right. 10 months will work because we'll subtract 260. You at least should have what I have written down. And I'll put the slide up there so you can copy it. What's 220 minus 260? Ooh. No. 220 take away 260. Negative 40 equals, and you check, that's 0, which it is, minus 4M. And now you can either guess and check or you can divide by negative 4. So M equals 10 months. 10 months to lose 40 pounds. I'd still take it. It's slow. And honestly, to lose weight, it is a slow process. To really lose weight, it's a slow process. You need to eat well, and you need to exercise. I exercise a little bit. There you go. Now I'm going to let you guys do this one. Come around and help you. Wake up. Do you need to stand up a little bit?